we can see that our circle rules are right here on the cheat sheet. Both values lie, and we have to take the square root of whatever it equals. Alright. So looking at this one here, we go up back 3, down 4. And we got to take the square root of 4, which is 2. So that means we got to go out 2 units in all directions. And then we draw our circle. So again, our center is at -3, -4, and the radius is 2. So we look at this one, we say, well, our center would be at +3, +4. And square root of 4 is 2, so our radius would be 2. So we go over 3, up 4, put our dot, we go out 2 units in all directions, and we make our circle. Alright, so that's circles. So these are absolute value. So remember, with absolute value, if you have trouble remembering, you can flip back to your cheat sheet. And we got all of our information there, the domain, the range, and how to find our vertex. So inside lies, outside tells the truth, so we go back 2, down 3. And the absolute value, since there's no number out front, it's like a slope of 1. So we go up 1 over 1. And then we connect the dots the best we can. Again, it should look like a V. So our domain is always all real numbers because it goes back forever and forwards forever. Now our range of this one, we have a low point of -3. So it's going to be y is greater than or equal to -3 because it goes up forever. Alright, so the next one. Our vertex, back 3, down 2. And this one's opening down. It's got a negative in front of it. So we go 1, down 1. Then we got to connect our dots. So again, the domain is always all real numbers. Now the range for this one, since it's opening down, it's y is less than or equal to the k value of -2. Pretty easy, hopefully. Alright, quadratics was the first one we talked about. And it's very similar. Again, it's on our cheat sheet. Alright, domain, range, the growth pattern, everything. So this one, our vertex would be at -4 and -3. And the growth pattern here is over 1 up 1, over 2 up 4, and over 3 up 9. But we can't go up 9. Then we flip all of our points over. And we connect our dots. So this one should look like a curve, not a V. So again, our domain, just like absolute value, all real numbers. Your range, well, this one's opening up, so y is greater than or equal to -3, the k value. Alright, next one, over 1 up 2, right? This one's opening down, so we go over 1 down 1. The negative sign tells us that. Over 2 down 4. And that's as far as we can go, so we connect our dots. Domain, again, goes back forever and right forever, all real numbers. The range, since opening down, is y is less than or equal to our k value, +2. Alright, so with these, I'm not going to worry about these on the test. You will see exponential functions on it, but the one thing I really just want you to know for these, as long as you have a calculator to graph them, that's what you want to do. But the one thing really to remember, well, there's two, but when that number there is in between 0 and 1, this is called a decay problem. And this also tells us the value of our asymptote, the -1. So when it's between 0 and 1, decay means this is a horrible looking graph. It goes down. So that's what this graph would look like. And it would approach -1 because of that -1. Now this one, notice how that value is greater than 1. So when it's greater than 1, we have a growth, which means the graph is going to look something like this. It's going to shoot up instead of down. So we should know those patterns. And again, this one approaches the horizontal line, y equals 1, because of that number out there. But you just need to know what an exponential looks like. All right, square roots. Again, we got square roots on here, I think, too. Maybe. There they are. All right, so this is kind of like half a parabola on its side, right? So I go back 3, down 3. Over 1, up 1. I go over 4, up 2, over 9, up 3, and then I can connect my dots the best I can. So your domain here, well, this is going to be x is greater than or equal to, because it goes to the right forever, the h value, -3. And then our range, since this one's opening up, we got what, y is greater than or equal to -3 as well. Alright, so the next one here, our starting point would be at -4, +1. And since there's a negative, we go over 1, down 1. And then we go over 4, down 2. Then we can go over 9, down 3. So notice how it opens down now. So the negative on the outside does not change how the domain, notice we still have a low point for our domain. So it's going to be x is greater than or equal to -4. Now your range is what changes, because you have a high point now for your range. So it's going to be y is less than or equal to negative, or +1, I'm sorry. Because it goes down forever. Alright. So completing the square, you should be able to find the value that completes the square. Remember, you find that by taking half of the b value and then you square it. So our c value here should be 121. So there's number 12 here, same thing. Half of 14 is 7. 7 squared is 49. So that's what our c value should be. Take half of the b value and square it. Alright, so let's go through these. This is what we've been working on the past couple of days. Again, the first thing is get that c value to the other side. Then we take half of b and square it. Half of -20 is -10. -10 squared is 100. Whatever we do to one side, we have to do to the other. So now I got y minus 6 equals, and now I know that this factors to x minus 10 squared. Last thing is to add 6 to both sides. Now I got y equals x minus 10 squared plus 6. Oops. Now it's easy to graph. So I can do the same thing with number 14. Get 9 to the other side. Then we take half of 8, which is 4. 4 squared is 16. So that's what we need to add to both sides. So we got y plus 7 equals x plus 4 squared. Our last step is subtract 7 from both sides. Down here. So y equals x plus 4 squared minus 7. And I don't think we had an example on or anything on our cheat sheet for that, so you might want to add that if you are actually using cheat sheets. Also, we didn't do any examples of the cubics or cube roots on the review, so just want to make sure we remember that a cubic has a domain and range of all real numbers because it goes forever in all directions. And after you find your starting point, your pattern is right here. You go over 1, up 1, over 2, up 8. Then from your starting point, go back 1, down 1, back 2, down 8. And if it's the cube root, you go over 8, over 1, up 1, over 8, up 2. So you might want to add those to the cheat sheet there if you're actually using this, but it should be helpful on the test.